I wanted to show you this problem because there's actually two different ways you could do this one. When we read this, it says, what is the volume of 25.2 grams of CO2 at STP? And once people see the grams here, a lot of times people will think, well, I could use the ideal gas law because that's giving me amount. I can change it to moles, and that's what N is. And since we know it's at STP, that's telling me pressure is 1 atmosphere, temperature is 273 Kelvin. We know what R is, and you just rearrange it to solve for V, and that will work just fine. So if we're going to do that, I'm going to take that 25.2 grams of CO2 and convert that to moles. Since I start off with grams of CO2, that goes on the bottom. And in a molar mass conversion, it's always 1 mole for however many grams you get off the periodic table. Oxygen is 16 a piece. There's 2 of them, so that's 32 plus another 12 for carbon, and that gives me 44.0 grams. When I multiply that out, you get 0.573 moles of CO2. So now if I take this ideal gas law and solve it for volume, what I have to do is divide both sides by pressure. So we get volume equals nRT divided by pressure. I know the amount of moles is 0.573 moles. I know R is 0.0821 liters atmospheres per mole K, and I know since it's standard temperature, that was 273 Kelvin. The pressure, since it's standard pressure, is 1 atmosphere. So now moles cancels out, Kelvin cancels out, atmospheres cancels out, and what I'm left with right now is 12.8 liters. Now that's one way you could do it. Now the other thing you could do is take advantage of this being at standard temperature and pressure, and I could actually use Avogadro's law for this. So what I can do is start off with this 25.2 grams of carbon dioxide. Do that same first step where I'm converting it to moles. Now Avogadro's law tells us that 1 mole of any gas at standard temperature and pressure is going to take up 22.4 liters of space. So what I could do is use that to set up the next conversion factor. I could put 1 mole of CO2 on the bottom because I wanted to cancel out with that one, and do 22.4 liters of CO2. Now the reason why I could do this is because it was at STP. If it wasn't at STP, this last step wouldn't work. Right, if you change the temperature or pressure, the volume changes. But at STP, 1 mole of a gas is 22.4 liters. I do this math, and I get the same answer, 12.8 liters. Oh, I wrote that wrong. Of CO2. Get the same thing there. All right, so like I said, it works because it's at STP.